Hello everyone, I welcome you all to yet another session on numbers. In the previous video, we were talking about last two digits calculations. So in this video, we are going to continue with that. So this is the second part of the same topic, alright. So finding the last two digits, part 2. So just to recap, in the previous video, what have we covered? So in the previous video, we have covered numbers ending with 0. Just a minute. We have covered numbers ending with 0, numbers ending with 5, numbers ending with 1. So these three were covered in the previous video. Now in this video, we will try to cover 2 to 3 more cases. So the fourth case that I will be taking up is numbers ending with 9. So how do we find the last two digits in this case? So I will try to explain this by using an example, a numerical example. But before I do that, there is a small trick I would like to share with all of you. Please listen to this. This trick can be used for finding the last two digits of any perfect square. How do we apply this? Observe. I want to find, let's say, the last two digits of 83 square. So 83 square ends in what last two digits? So the process is, you look at 83, consider the closest multiple of 50. So for 83 it is 100. Consider the closest multiple of 50. So for 83 it is 100, closest multiple. Take the difference. So 83 and 100, the difference is 17, right? And after that you may claim the last two digits of 83 square will be same as the last two digits of this, which is going to be 17 square, and 17 square is some value that most of you already kind of remember. So 17 square ends with 89, it's 289. So the last two digits of 83 square is going to be 89, we say. Let's take one more example. Say I want to find out the last two digits of 48 square. So consider the closest multiple of 50. So closest multiple of 50 is going to be 50 only. So take the difference, so 50 minus 48, so last two digits of this will be same as last two digits of this, which happens to be 2 square, and 2 square last two digits is not 4 but 04. So thus 48 square is going to end with 04, we say. One more example for your practice. Say I want to find out last two digits of 137 square. Closest multiple of 50 is 150. So take the difference. So last two digits here will be same as last two digits here, which is 13 square. And how much is 13 square? 169. So last two digits are 69, we say. So this way we can find out last two digits of any perfect square. If you remember, if you memorize the perfect squares from 1 till 25. So 1 to 25 you need to memorize. You will be able to manage the last two digits of any large numbers perfect, which is a perfect square. So I will take an example. Numbers ending in 9. You take randomly an example like, say you have a number like 29 raised to the power 142, suppose. I want to find the last two digits. So for answering this, I need to realize one small point before I proceed to the next step. In powers of 9, 9 power 1, 9 power 2, 9 power 3, 9 power 4, there is a place, there is a position where the 9 power something will end in a 1. If you notice, the value of k is 2. 9 power 2, 81, ends with 1. See, why this ending with 1 is important is, if you remember in the previous class, for numbers ending with 1, we shared a formula. Now, the moment I am able to convert this number, 29, into a number ending with 1, I can use this formula. That was discussed for numbers ending with 1. I will just show it to you. Observe. So, I notice in case of 9, 1 will be obtained if you raise it to the power 2, 9 power 2. So what I will do is, I will write this power 142 as, can write it as 29 square. So 142 is 2 into 71. I will be left with 71. Now listen. Look at this number that I am circling, 29 square. So what are the last two digits of 29 square? Now can I say from that process, 29 square will be same as 21 square, right? 50 minus 29. So what is 21 square? 441. Hence can I say last two digits of this circle number will be 41. And please note, I only want the last two digits of this number. I don't want the entire value. So this will reduce to 41 to the power 71. Now look at the process. For any number ending with 1, we can find the last two digits using the formula. What is that? For numbers ending with 1, we'll end with 1. What about 10th digit? 10th digit will be product of 10th digit here and units digit here. So 4 into 1, which will give us 4, and hence 41 is going to be the last two digits of this number. Now just visualize, if you don't know this process and you have to find the last two digits of 29 to the power 142, it would be a very time taking process. You have to multiply twice, 29 square, 29 cube thrice, then 4 times and 5 times, then maybe after a while you will get a pattern. Then after a while, after you calculate for so many times, I don't know how many, but you will get a pattern much later. So based on that pattern, maybe you can answer this, but it will take few minutes. This method out here is definitely going to take around 1 to 2 minutes, not more than that. 1 to 2 minutes on the higher side, that is when we are learning it. Once you have learned it enough, I think we can do it much easily, very easily out here. Okay, I hope we are clear with this. Numbers ending in 9. So numbers ending in 9 can be dealt with like this, right? So now we'll move on to the next case, which are the numbers ending with 3. So for explaining this also, I'll take up an example. Say I have 43, because I want last two digits, 4 and 3 must be there, raised to the power, say 46. So I want the last two digits of this number. Okay, so how do we do it? So again, if you notice, for powers of 3, 3 power 1 ends with 3, 3 square, it doesn't end with 1, 3 cube, it doesn't end with 1, 3 power 4, 81, it ends with 1. So that means even in case of powers of, even in case of numbers ending with 3, for some power, you will definitely get a number ending with 1. Now what is that some power? Power 4 it is, right? So what I'll do is, can I write this as 43 square? Now 43 square is not going to give you 1, right? So what I'll do is whole square. So look at this, 2 into 2 is 4. And I am sure 3 to the power 4 ends with 1. So 43 power 4 will also definitely end with 1. We'll see how much value we'll get. Whole to the power. Whole to the power. How much is left? 46. If I take out 4, 11 will be left, right? 2 into 2 into 11 is 44. Into 43 square separately. I'll write that separate. Now notice, what will be the last two digits for this number 43 square? So can I say 43 square last two digits will be same as 50 minus 43, which is 7 square. So it's going to be 49, this value. This square is still intact, we have not used that. Whole power 11 into 43 square, we just now saw, will be 49. Okay, stay with me. Next, observe 49 square. Find the last two digits of 49 square. So what will be 49 square equal to? Can I say last two digits of 49 square will be same as 50 minus 49. I hope you are following this. So closest multiple of 50 is 50 only. Difference is 1. So last two digits of 49 square will be same as 1 square, which is 0, 1. So 1 to the power anything will be 1 only. 1 into 49 will be 49 only. So hence the last two digits for this number 43 to the power 46 will say it will end with 49. Okay, I hope we are clear with this. There is a small point that I would like to explain here. So sometimes what happens is the powers given are so large that the overall simplifying process, there is a risk that we might go wrong somewhere. For example, I had 46 here. So since we know little basic mathematics, so we were sure it will be 2 into 2 into 11, 44 and 2 separate. But imagine someone else or some other larger number where there is a chance that you may go wrong in such breakup. So for such cases, we have a small point. So the point is the last two digits repeats, always repeats with frequency of 20. With frequency of 20. Now, what do I mean by that? So, that means, so 43 to the power 46, the power is 46, the last two digits whatever they are, say AB, suppose AB, 43 power 66 will also be AB. So, please look at the power, it is increased by 20. So, 43 power 86 will also be AB. Now, reduce it, 43 power 26 will also be AB. Reduce it further, 43 power 6 will also be AB. So, that means instead of solving this question, I may solve a simpler question, right? So, the idea is to simplify the power. Now, how do we do that? Observe, I will just show it to you and so that we can match the answers here. So, you had 43 power 46. So, I told you the powers will, the last two digits will repeat with frequency of 20. So, that means I can reduce the powers by 20. So, 43 power 46 will be same as 43 power 26 will be same as 43 power 6. Last two digits will be same. So, what is 43 power 6? It is 43 square, 43 square, 43 square. Stay with me. 43 square last two digits will be same as 50 minus 43, 7 square last two digits, which is 49. This will also be 49. So, will be this, right, 49. 49 into 49 into 49. Now, again, last two digits of 49 square is same as 50 minus 49, 1 square, 1. 1 into 49, again I will get my answer as 49. You will get the same answer. So, this way if we want to simplify by reducing the power, we can do that. However, please note there is an exception for this, which I will take up in the next video. But let us take up one more example for numbers ending with 3. Say someone asks us what will be the last two digits of 63 to the power 124, suppose. So, we just now discussed we can reduce the power, right? So, 63 power 124 will become what? 124 can become 104, can become 84, reduced by 20 every time, reduced by 20. 84 will become 64, 64 will become 44, 24, and finally can I write both will have the same last two digits, 63 power 4. Now, what is 63 power 4? Correct? Now, 63 square will be same as, the last two digits will be same as 63 minus 50, the closest multiple of 50 is 50. The difference between 63 and 50 is 13. So, last two digits will be same as the last two digits of 13 square, which is 69. Same thing here, 69. So, thus we will get 69 square. So, 69 square, the last two digits will be same as 69 minus 50, which is 19 square, and 19 square we all know is 361. So, hence the last two digits will be 61. So, this is how you can simplify a given problem with a large power. You can always reduce it by 20. One simpler trick is you divide the power by 20 and take the remainder. That will be the reduced power. Okay, that will be the reduced power. So, in this video, we have only covered 9 and 3. I hope you followed, and of course, this very important trick, right? So, to say the last two digits of any perfect square can be calculated. So, with this, we will end the video here. In the next video, we will take up the remaining part. So, I will just not be repeating it. You can just check out these things, alright, these social media platforms. We regularly upload content there, alright. And yes, if you are looking for classroom coaching, then please reach out to our nearest time center. So, we now that the CAT is very close, alright, we kind of schedule our batches very at short intervals, alright, short frequencies. We will be having so many batches coming up. Please visit the nearest center. On that note, let me end the video here. Thank you and all the very best.